up on the top part of this. And then the last time, or the last time it reaches 32 in the spring, first time it reaches 32 in the fall on the bottom here. And that last freeze date is getting earlier for this station and getting later in the fall for the station. But there are problems when you use station by station. The reason why we're seeing some of these bars stick up near March 1st is that there's some missing data, or there's some gaps here. And then that becomes a problem of, does this apply over a larger area? So we had a visualization, but it doesn't always work well, and it's not only convenient for being able to look at across the region. So we're going to talk more about that as we go along. The other reason for this, and this one's a purely selfish one, is that when I go to give talks and talk about the various climate changes and their impacts on agriculture, we're able to look with more granularity, more locally, county level, or even lower sometimes, at temperature and precipitation changes. But when we look at frost freeze date changes, this is the best graphic we had. This was from, I think, the maybe two climate assessments ago, on the change in frost, and we're looking at frost-free season length. So that this was the increase of our growing season, ranging across the U.S. So it gives you a nice view across the U.S. But if you're growing something, in Michigan or in Iowa or in Illinois, you want to know how things are changing locally. This doesn't give you a lot of help. So I would show this, but I would really struggle to be able to talk about frost freeze date changes locally. So purely selfish on my part. What this is driving from a physical standpoint, things like bud break in fruit trees. This is drawn from another publication, a USDA publication on climate indicators for agriculture. One of the issues related to changing winter temperatures, and this involves a number of different pieces, is earlier bud break in fruit trees, for example. Now, while we have changing freeze dates, but if we have bud break in fruit trees occurring even earlier than the freeze date, or the variability in freeze date, we end up with problems with freezes occurring when plants are much more vulnerable, and that's become a fairly common, not a fairly common, but more frequent issue across our region. And though we grow a lot of corn and soybeans, in our region, we also have a lot of specialty crops. This is an image from Michigan, something we've seen several times frequently, frozen apple blossoms. This is back from May of 2020. From a numbers standpoint, I pulled images from one of our partner hubs, the Southwest Climate Hub, who pulled out data, economic data from USDA Risk Management Agency on the amount of damage, or the amount of indemnity payments because of payouts on crop insurance because of some kind of loss. And on the right hand side, I've got data for Michigan, and this is for payments, our RMAM payments from 1989 to 2020, this whole period of record. So what I've shown here are the payments by year, and you'll see there was a big one in 2012. Remember, that was a big drought year. It was also a big loss year because there was very early dormancy break, and then a semi-late freeze did, I think this was almost $50 million in damage. And the damage in Minnesota in Michigan in this case, primarily apples, grapes, cherries over this whole time period. In contrast, we look at Minnesota, where we have a number of different years where we have damage. More of their freeze date issues are not spring, but are late season. Things like sugar beets, corn, and soybeans, where we have a delayed crop, and then we have a near average or maybe a little bit of an early freeze in that situation. So we have issues on both end of our spectrum, spring and fall, and some of the issues related to them. Now, just a couple other things we're going to see as we look at this as we go along. The trend varies by location. From where you are, that makes a difference, which is why we're trying to do this, so you can get a more local look at what's happening in your area. Interesting also varies by temperature cutoff. We're going to show as we go as part of this. we talk about frost freeze, which is 32 or 28, but we also look at some other temperature levels to give you a contrast or the impact of first or last at some of these other temperature levels. And they don't all look the same. In fact, in some places, the trend is kind of counter to each other. And we don't have a good over period of time. So there is a question in there about change over what period of time. We'll probably talk about that, but just to get that out there, this is 1950 until the present. And the reason for this is the data set we were able to use for this was available from 1950 until the present. So we'll talk about that, I'm sure, more as we go along here. Okay. So that gives you kind of a background on why we're trying to do this. We hope that people find this information useful, this tool useful, and look forward to more conversation about it. This is some contact information for us. If you'd like to contact us and find out more information, you've met most of the Hub staff so far, and that is a picture of us. So anyway, okay, we're going to defer most of the questions again till the end. Now we're going to turn it over to Melissa Widhalm to talk a bit more in detail about the tool.
Thanks, Dennis. You hear me okay?
Great.
Excellent. All right. So hello, everyone. Thanks for joining. I was just checking. We have over 100 people on the webinar, so that is great. We really appreciate you taking the time this morning to learn about our new tool, learn about what we're doing with this tool. Before we jump into that, just a little bit about us, the Midwestern Regional Climate Center. We are one of 6 regional climate centers that are funded by the National Oceanic and Atmospheric Administration to provide climate information and climate services across the U.S. We ourselves at the MRCC have been providing climate services since 1982. However, our partnership with Purdue University started just a little over a year ago. Prior to 2021, we were located at the University of Illinois. And since the center has moved, we now operate out of West Lafayette, Indiana. So I join you today from warm, sunny, beautiful West Lafayette, Indiana. While at the MRCC, our services really can cover any sector, we do specialize in services for agriculture and for water resources. And although our geographic focus is the Midwest, so you can see in our logo the 9 Midwestern states that we focus on, our tools are really applicable beyond our 9-state region, including the tool we're going to learn about today. Dennis, you can go to the next slide. So really today we're here to talk about the Freeze Date Tool. And I want to demonstrate for you the functions and features of this new tool, which, as Dennis had mentioned, it was really designed for exploring the trends in and the climatologies of freeze dates and growing season length. We are hosting this tool, the Midwestern Regional Climate Center, and it was obviously developed in partnership with Dennis and his team there at the USDA Midwest Climate Hub. At the end of the demonstration, I will pop up a slide that has my contact information along with a link to this tool and a QR code if you're into that, and you can just snap a picture and pop up that tool on your end. This tool is really designed to be modern, to be interactive, to let you move easily between this regional view and a more detailed localized scale. And so Dennis had started to mention our data. What we are displaying in this tool, because I'm certain that question will be asked, we are looking at county level gridded data from ACIS, the Applied Climate Information System. And this data set is based on station observations that were aggregated to a county level. So the benefit of doing that, of using this county level gridded data set, is that it gives us continuous data from 1950 to 2021. When you're looking at individual stations, you can have missing data throughout that record, and that can complicate our ability to look at trends, to look at climatologies, to look at all of that information. Now be aware, your hyper local freeze conditions might be different than what is shown, by a few days, what is shown in this tool. We have influences of topography, we have data availability, all of those things that sort of play into that. But in reality, that's not much different than the cautions we already use when we're looking at individual stations, right? We don't have individual stations in each and every one of our own backyards. So we already are kind of making that adjustment for how does my specific location compare to the nearest weather station. You want to use those same cautions when you're looking at how does my countywide data compare to my exact location. So we're going to just go ahead. I'm going to do a live tool demo. I have slides available if for some reason the site crashes or something goes terribly wrong, but I think doing a live demonstration of our tool will be much more entertaining and much more engaging. So let me go ahead and switch over to that. Now, before we do that, I do want to ask this one question. While Dennis was talking, it dawned on me, we have over 100 people here. We did not make you register. We don't know where you're coming from. This tool is available for the North Central and the Northeast US. There could be folks who are located outside of those regions, but if you want to just pop open a browser or grab your phone, and you can see here on the screen, we have a Mentimeter poll asking, from where are you joining us today? And so if you go to menti.com, as it's shown up here on the URL, and you use the code 84052377, you can go ahead and drop a pin on the map. It might not be super precise.
Melissa, are you sharing a screen on?
I am sharing the screen. Are you
we still just see the map.
Is it populating now?
Now you can see, yes, okay.
Yes, so people have to start popping in their locations. There you go. So as that happens, you know, I'll keep an eye on it, and we can come back to that. But like I said, I was just curious, where are our participants joining from today? So I see lots across the North Central US, which is what we expected. A couple in the Northeast. Oh, we have somebody from Georgia. Now you're going to see that our tool covers the North Central US, the Northeast US. We can get into it a little bit more in Q&A. But as you could imagine, things become a little bit trickier when you go to locations that have a lot of topography or that don't have a typical frost freeze cycle. You know, if you have many years where you don't hit freezing temperatures, for instance, it's not to say we can't offer this tool. We just would need to make some modifications beyond what we have available in this first pass. So if you're located outside of these regions, don't worry. We are looking at and thinking about how we can get these data in this tool to other locations. So go ahead and keep popping that in, but I'm going to go ahead now and switch over to our tool. Get some things out of the way that you can't see here. All right. Are you seeing the freeze date tool now? All right. I'm going to take that.
Yes, we are. Yeah.
All right. So let's just orient ourselves a little bit. When you come to the tool, this is the first page you're going to see. And the general way this tool works is that across the top here, when you're in the map view, these are actually buttons that take you to a different map. So you can click on them and see across the top here, we have first fall freeze date, last spring freeze date, growing season length. We also have some trend maps at the bottom. We'll get to those in just a moment. But if you look across the top, all of those rectangles are actually map buttons. So you click those to change what's happening in the map. Now, I had said this is an interactive tool. And so if you hover over anything on the map, you'll get a tooltip that pops up with the information about that location. So it gives you the location, tells you the parameter you're looking at, and then the value for that parameter. We'll come back to that in just a moment. If you bring your eyes to the right side of the tool, you'll see where you have the ability to customize and control the map and what's being viewed. So we have freeze date temperatures. It's defaulted to 32, but like Dennis said, sometimes 32 is not your freeze date of interest. Maybe it's 28, maybe it's 37, whatever it might be, we have the ability to control that. We have the ability to change if we're looking at average, or maybe you want to know the earliest date in the period, or the, earliest 10th percentile. So that means, only 10% or fewer of years have a date this early, right? Those are the types of statistics that we can view. And when we click those, it changes the map. I'll show you that in just a moment. If we keep going down the right-hand panel, you'll see some informational text about who funded the project, where the data are coming from and for what time period. And then we have this about page button. I suggest clicking on that. It does provide definitions for our statistics that we're looking at, tells you more about the source of these data, the trends and how they're calculated, and other relevant information about the fundamentals of this tool. And so again, you can hover over any of these counties, get the county information. On each map, this piece of information here in the top left is really important. It tells you a summary of what you're looking at. So here, average first fall 32-degree freeze date, right? So we're on the first fall freeze map. We have 32 degrees selected with an average of the statistic that we're looking at. So let's go ahead and look at, say, 28 degrees. And I want to look at the date of early 28-degree freezes. So I'm going to click on early, and just like that, the map updates. It's fast, it's quick, right? It's meant to be speedy. And so now you made those customizations, and we can see up here in the top left, we're looking at the early date of the first 28-degree freeze. So I live right here in Tippecanoe County, and we can see that the early freeze can happen October 8th. What about the earliest? The earliest. Now remember, this is 1950 to 2021. The earliest we had was September 22nd. That's tomorrow. Thankfully, I don't think we're going to get down to freezing tomorrow, but you can see how you can use this tool to find that information. We can do the same thing, just kicking over here to last spring freeze. I'll pick on my location again, but this time we're going to go to late. Let's look at the 90th percentile, and I really am interested in a much harder freeze. Let's go down to 25 degrees. And so again, we're looking at, we have highlighted here, last spring freeze date, the 90th percentile. So that's telling us, this is a rare event. Only 10% of the record has freeze dates later than this, because we're looking at that last spring freeze in the late option in 25 degrees. And I come down here to Tippecanoe County, and I see that the average date for that is April 14th. We go up further north, May 19th. So it can be pretty late in the spring up in the Upper Peninsula of Michigan when you're still getting 25-degree freezes. Let's go ahead and take a quick look at growing season length, and then we're going to move over to the trends. So it's the same idea across the top. Again, these are all map buttons. Down the right-hand side is where you go to customize the map view that you're looking at. And so we can say here, this is looking at growing season length. So we're describing this as when that number of days when you are consecutively above that threshold temperature. So let's go ahead and move this back to 32, because that's a more standard way that people first think about the growing season. And so growing season length here, we're looking at the number of days from when you have your average first or average last freeze in the spring to your first freeze in the fall. Okay, looking at 32 degrees. And so here in Tippecanoe County, where I live, on average, our growing season lasts 172 days. We go up further north, kind of along the Canadian border here, and that growing season on average is 129 days, right? We have shorter growing seasons in the north than we do the south. That shouldn't be surprising to anyone. And just like on the other maps, we can look at the shortest, the short, the long, or the longest that we have. Now, these are all useful for looking at this regional picture. After we go through the trend maps, I'm going to show you that if you want to get much more detailed into this information, you can click on these counties and drill in. But stay tuned for that. We'll get there in just a moment. Let's go ahead and look at trends, because one thing that Dennis had talked about, it's not just the averages or the earliest and latest that people have interest in. We are also curious to know, how are things changing? So what we have here are trends, and these are based on simple linear trends. So I scrolled down so we can see the whole region here. So this can be pretty highly influenced by the start and the end of your record, right? So we're looking at each individual season and then applying that linear trend line across that record from 1950 to 2021. All right, so there's other ways you can identify trend. We are just doing it in a simplistic way. So same idea. Here at the top, it's showing us what we have the trend in first fall 32-degree freeze. So we're in the fall season right now. We're looking at how this has changed over time, right? Trend, how it's changed over time. We're again looking at 32 degrees. We can customize that if we want. And we've added an additional feature for those who are maybe a little more interested in statistics, where we can look at the statistically significant trends. And so if you're really looking at those strong trends, right? Statistically significant. If I hit that button, I have to actually click it. If I hit that button, it'll filter out all of the counties whose trends are not statistically significant. So I'm just going to go back to viewing all counties. And again, we can hover over and see, for instance, here in Hamilton County, New York, the trend in the first fall freeze shows us that 3.8 days later per decade. So you can do the math there, right? We're looking at 7 decades worth of information. You can take that 3.8 and multiply it by 7 if you want to know how many days later from the beginning of the period to the end of the period, just based on that simple linear trend. We can do the same thing with spring freezes. We can do the same thing with growing seasons. I'll just go ahead and click on that growing season. We're going to leave it at 32. Let's just look at those significant locations. I'll scroll down so we can see the full region. And again, you can see as you hover over, a lot of places here in the north, we're looking at 4 days per decade longer, 3 days per decade longer. So we're showing some lengthening. I want to drill in now that you kind of have a basic understanding of the spatial view. Remember, one of the things that I had said early on when we started, this tool is really intended to let you take that regional view and then very quickly and easily get down into the weeds of that data for the county level. And then really quickly and easily get back to that regional view. So let's go ahead and do that. We're going to just pick a place. Let's go Portage County, Wisconsin. Let's pick on Portage County. So in any of the maps, if you click on a location, this is going to be the first view you see. Let's walk through this. It can feel a little busy at first. I promise it'll make sense in just a moment. So the same kind of thing all across the top, these gray rectangles are buttons. You can click those to see different views. We're not in the map. Everything you click is now specific to Portage County. And if you feel a little lost as you're clicking across and you think, what am I on? You can always refer back up to here at the title, where it tells you exactly what you're looking at and for your location. If you say, forget this, I want the regional view, you can click that back to map button. And if you want to customize anything on the different graphics that you're looking at, again, that's all located down the right-hand side. So here, what we're looking at is the freeze date trend. So what we have plotted here, if you look at these columns, 20 degrees Fahrenheit, 25 degrees Fahrenheit, 28 degrees Fahrenheit. So we just did a side-by-side view for all the different freeze thresholds to look at each year's data. So if you see here at the bottom, each container shows from 1950 to 2021. You can hover on any individual point and see, for instance, the first fall freeze of 20 degrees in 1994 was November 16th. So as you look on the left-hand side, these are dates. So we're going August 1st, September 1st, October 1st, November 1st, December 1st, and all the dates in between. Because again, this is the fall freeze. So we're focusing in on that fall point time of the year. Let's make this a little less busy. I am going to just look at let's look at 3 values. And so you can see what I just did there. I went in, I clicked the button, I select just the ones I want to look at, and now I'm seeing that same view with fewer columns. Let's say I just want to look at 20 degrees. I can do that as well. And just that quick and easy, same kind of function. I hover over, I can see the dates. Now, here's an interesting feature that you might not have realized is there. If you want to zoom in on this graphic, you can pull these little bars here and restrict it. Say you only want to look at data from 1970 to 1990 for whatever reason that might be. Now you can look at just the data for those time periods selected. Shown on the graphic, that solid line is the trend for the period you're showing, and then you have those high and low percentiles showing on these lighter colored bars as well. All right, so that's one way of viewing the time series, as we call it, right? Those data points, those individual data points over time for the county that you're in. Let's look at this slightly differently though. I just zoomed into 2 decades. Maybe that's not the most efficient way to do it. If you're interested in this data by decades, click on this freeze date by decade button, because now what we're doing, we are taking those data and we are sorting it by decade. So same functions across the top are your buttons, across the right are your controls, and in the middle, now each row is looking at the decades. So here's 1950s. Each point are the 10 years within that decade, along with the box plot, box and whisker plot. So if you're a little more statistically savvy, that has meaning to you. And you can look at this for all of the decades available. So we have 50s, 60s, 70s, and you can see in this particular example, here's our average for that decade is the dashed line. And you can see this average in this location getting steadily later and later as the decades go on. Some locations don't have this nice, simple pattern of going from, freeze dates happening earlier in the early part of the record to freeze dates happening later in the later part of the record. Some of them jump around a bit. This is localized climate in the works. So I encourage you to check it out in this view if you're interested to see how are these different decades contributing to the overall trend. All right, and again, with all of the other ones, we're looking at 32. You can do this for whatever set of freeze dates you want. So here I'm looking at 25 degrees. And if I want to isolate it and only look at specific decades, I can do that as well. All right, let's move on to the growing season. We're just about done with this tutorial and then we can open it up for Q&A. This is probably one of my favorite graphics that we produce in this tool because it shows so much information, but it's actually quite simplistic. So what we're showing here, I'm going to scroll down so we can see the whole thing. We are looking at the trend in the growing season. Each individual bar, if you see here, this is date. So each individual bar is showing the length of the growing season, as well as the start and the end of the growing season. So here we're looking at 25 degrees. I'm going to put this back to 32 degrees because I think we're just more accustomed to thinking about 32 degrees as freeze thresholds when we're thinking about the growing season. But again, you can define it however you'd like. So the color of the bar, the length of the bar is representing how long the growing season is. You can see the top of the bars, that's when the growing season started for each individual year. The bottom of those bars is showing when it ended, right? When it crossed below that threshold for the year, that minimum temperature. So you can go across time and see for each individual year. If I scroll way down here, you can see the years there at the bottom. This dashed line on the top and bottom, that's showing your average first freeze, or sorry, your average last spring freeze and your average first fall freeze. These solid gray lines are showing that linear trend line. So again, you can glean a lot of information from this graphic. For instance, in Portage County, when we saw that they were having a longer growing season on that trend map, we can see just from here that that trend is being influenced both by spring happening earlier and fall happening later. Okay, you can see that by these trend lines really going off of that average in opposite directions, right, for each season. And again, just like all of our other maps, if we want to zoom this in, and recalculate that trend. We can see it for a very specific piece of the record, or, we could see it for the full length of the record as well. And it's responsive in real time, meant to be fast, meant to be easy. If you want to download any of these images, there is a download button. And again, if you have questions about the data, don't forget to hit on that About button. So the last three tabs here on these, remember all of this that we're showing here at these charts, this is for one particular county. If you want to see a different county or you want to see the regional view, you go back to the map. All of the information we're showing is great in graphics, but sometimes people want to do their own thing with the data. And so we put the data into tables. So if you're not as visual of a thinker, if you want to see it in a more tabular format, or if you simply want to download the data that we are presenting, this is where you would access that data. So we have freeze tables, we have growing season tables, and we have summary statistics tables. It is a lot of information, right? So here we're looking at, for the freeze dates, we're looking at all temperatures. Again, you can customize that, take off the temperatures, you can shrink the range of temperatures, and in the table, we're going to display each and every year for each freeze level you have selected, the fall freeze date, the spring freeze date, and the length of that growing season. We can kick over to the growing season table, see very similar information, when that growing season started and ended and the length, or we can come over to the summary statistics, and now we're seeing a whole lot of information, pretty much combining all of that information that we had in all of the maps and tables into this one mega table. All right, so I'm going to head back to the map. And with that, I'm going to ask Dennis, was there anything that I did not show that you would like me to show before we open it up to questions?
I don't think there, downloading data. Yes.
What about downloading data? Yes, so we can download the images, or if we're in a specific location, we can download the data for these tables, which are all of the data that go into populating the map. We don't have a function to export all of the data for all of the counties. We can ask our data programmer about that. It is a pretty hefty data set. So you can always contact us for that, but we don't have a button on there to just do a mass dump of all of these, hundreds of counties.
And I think the download data for a local place is a good thing too, because if you wanted to play around instead of doing a linear to do something else with that, give you an opportunity to play around with that.
That's right.
Let's say it also might be worth it also might be worth noting, I think in the various plots, the option to how to change between showing the first fall freeze to the last spring freeze, for example, on the trend map. I don't know if you did show that and I missed it, or so in the plots, if you select a county.
Oh, in the plots, yeah. Okay, so if we go back to what county were we picking on? Portage. Doesn't matter which county we're in. I was just gonna, I'm obviously not from Wisconsin. We're just gonna pick on Jefferson County. So when you are in these graphics, you can see here, choose your freeze date. Do you want to look at the first fall or do you want to look at the last spring? And so on these different options, whether it's the freeze date trend or the freezes by decade, when you're on the maps, there was a whole separate button, look at fall, look at spring. If you want to do that when you're zoomed into the county level, there is a box where you can toggle for fall or spring. That's right here on the right side panel. And what happens is it updates your dates, right? So now if we're focusing on spring, we're looking at March, April, May, June, instead of when we were on the fall maps and it was September, October, November, December. So that is one quick and easy way when you're already zoomed into a county to be toggling from fall to spring. Now, if you come back to a map and you see your county is highlighted, you can simply click off of the map onto something else to re-engage the full map view, or you can click on that county and that will again reinstate that full map view. other questions or you want me
Yeah,
to
I
just
think
kick it over to
Melissa,
you,
if
Lauren?
that's good for if your tutorial is complete, I think we can go ahead and enter a Q&A session. There are a couple of questions that have popped up in the chat. So I think I'll draw our presenters to that first, and then folks can either continue entering questions or comments in the chat, or feel free to use the raise hand feature and we can call on you as well. So first, I'll send it over to Dennis. There was a question about the 50-degree threshold for corn soybean. So if you want to speak to that.
Right, and that came from Adnan in North Dakota. Understood. I think I understand where you're trying to come from on that, Adnan. But unlike, corn and soybean, if you fall below 50 degrees on both of those, that doesn't end your growing season. That's a critical temperature for accumulating heat. But if we have a night that goes to 45 and then the next day we go above 55, corn and soybeans can continue growing. If you go below a freeze temperature, that's where we're trying to head. What is the end of that growing season? Because when you go below that freezing temperature, it doesn't matter what happens after that, that ends your growing season. So that's the target where we're trying to go. That said, I suppose I don't think it preclude us from being able to add other temperatures. If there were other temperatures, we just grabbed a few that we thought were important for our different efforts.
And there was another question in the chat about the Chicago area and impermeable. No, I lost the question. Oh, here we go. Does Chicago area have earlier fall freeze because of rise in impervious cover? So Dennis or Melissa, if you could speak to that. Okay.
Yeah, Melissa, can you pull up the trend over that area? You have a couple different things going on in Chicago. Certainly you have a heat island issue. You have a city that's growing larger, influencing more of the temperatures around it. So you have a heat island issue. You also have a lake issue that comes into play there too. Looking at the different trends, you see lake influences. So there are some things that we see here that we need to spend some more time dealing with and trying to figure out what's going on. And that's what makes it kind of fun to play around and see what's there. Melissa, Jonathan, do you want to add anything to that?
I
Okay.
don't think so.
Covered it.
Yeah.
Okay.
I'll go ahead and call on Virgil has his hand up. If you want to, you feel free to unmute yourself, Virgil, if you can.
Yep, I did. Just wanted to comment, the fellow from, I believe you said it was North Dakota, Dennis, who was asking about the 50 degrees. You might find some use out of the growing degree tool that's on the U2U website. Dennis, would you want to comment about that?
I'll let Melissa comment on that one.
Right, so the Useful to Usable was a USDA funded project to help integrate climate information into agricultural decision making. And we developed a suite of tools. I say we because I was a project manager on that project, and several people on this webinar today were involved in that in various capacities. And one of the tools is the Corn Growing Degree Day tool. I can drop a link to that in the chat, or if somebody else wants to drop a link to that in the chat.
I think I got it, Melissa, if it's the right one.
Excellent. So that's really a tool that is operational, and it helps you track. You can customize it for your corn, for your location, when you planted, different thresholds that interests you. And you can track over the growing season the corn phenology based on the growing degree day accumulations. And that can really be useful early season, late season, when you're planning out planting and harvest, when you're trying to understand your risk of having a freeze hit your crop before you've reached maturity, because it does, again, project out based on climatology and based on short-term weather forecasts when different dates of phenology will occur, when you're going to hit certain reproduction stage, or you're going to hit maturity, or all of that. So the Corn Growing Degree Day tool is really tailored to that. And it was developed a little over 10 years ago, and it's still in pretty high use today. So it says a lot to the work that went into that tool. And so, Dennis, anything else to say about Corn GDD?
Yeah, it only took 5 state climatologists to contribute to it to get a tool that was useful.
And a whole boatload of social scientists.
And a couple programmers who knew what they were doing too.
That's right. That's right. And I will say, just a shameless plug, we are just about done updating the Corn GDD tool with the new normals period, the 1991 to 2020. 1991, whatever. Okay.
91 to 2020, yeah.
You just drew a blank there on my math. So right now the tool has 1980 to 2010 normals. And so we are getting the new normals in there. You'll see them for the next growing season. I just saw an example of that a few days ago, and it's looking wonderful. So check it out.
Melissa, I don't know if you addressed this earlier or if I missed it, but there was a question about what format the download function for the tables generates.
I will kick that to Jonathan. I can click on the button and see what happens. I don't know it off the top of my head. Otherwise, Jonathan can give it a go.
Yes, if I'm not mistaken, it gives you the option to select either CSV or an Excel file. The really only difference is how it formats the column labels and things like that. So if there's like a nested columns where, for example, the temperature is at the top and there are several columns for that temperature, in Excel format, it keeps that one long column and it looks a little more pretty. In a CSV format, it obviously separates those out and makes it a little more easily available for use in data analysis or other programmatic things.
And Melissa and Jonathan, I think a good question for you. There are a couple comments and questions regarding expanding this to other regions. So could you speak to the feasibilities and challenges of expanding this beyond the Midwest and Northeast?
Yeah, so we initially developed it for our region and expanded it a little bit west, a little bit east, and we have interest in, we have data for all of the rest of the country, but we have some challenges to overcome with the visualization and integrating it into the tool. When you go further south and you get into locations that don't have freezes every year, and you get into some challenges when you head west and you have a lot of topography in very large counties, right? So if we're looking at county aggregated data and you're in a very large topographic, area with a lot of topographic changes, is that really the best way to represent the data? Or do we need to look at a finer scale of a grid or using station data? So yes, we have talked about it. We're interested in it. We just need to figure out how to overcome those challenges to make sure that the visualization and the functionality of the tool makes sense. Jonathan, you have other comments to add to that?
I think you largely covered the major points. I would say that as far as the current presentation of this tool is concerned, expanding southward to the southeast and south central United States is certainly possible. Again, like you said, it's just a matter of how to account for, for example, what does a growing season on that little bar chart look like if the location never actually had a 20-degree Fahrenheit freeze that year? Does that mean it extends all the way from January 1st to December 31st? Do we say that the growing season was 365 days, or do we say it was from, when the last freeze was like 2 years before and the next time it reached that temperature 3 years later? That's, hard to, it's one of those things that it just kind of involves some discussion and thinking about how to adjust how the data is being presented